In this short video, we are going to present unit number 1 of the ARIS course. This unit is about the foundations of artificial intelligence. The material of this unit has been developed by Javier Bejar and Javier La Rosa from UPC. The unit is divided into 6 independent lessons. In lesson number 1, we will address the definition of artificial intelligence. We will see that there is not a unique definition of artificial intelligence, and this is because there is not consensus on the definition of intelligence. Some definitions are based on the idea that intelligence is a human feature. So, with this idea, AI systems are those that act or think like humans. Other definitions prefer to connect intelligence with the concept of rationality. So AI systems should act or think rationally. Another approach, another way to define artificial intelligence is to enumerate the topics that it covers. We will see that AI has historically addressed some fundamental areas, such as general problem solving, knowledge representation and reasoning, and machine learning. And these fundamental areas have been used to solve some applied problems, such as natural language processing, perception, or robotics. In the second lesson of this unit, we will see how AI has defined a very elegant abstract framework for general problem solving. The idea is that this framework allows us to unify many different problems as the problem of finding a path in a possibly huge graph from an initial node to a goal node. Different versions of this idea are state space search or adversarial search. We will review some of the most important algorithms, like A*, that help us navigate efficiently in the graph, searching for the goal state. And we will discuss the pros and cons of these algorithms. In the third lesson, lesson 3, we will see how AI represents knowledge. First, we will clarify that knowledge and information is not the same thing. Information is a set of basic facts without any interpretation. However, knowledge is the interpretation of these basic facts, producing high-level and structured content. As an example, if you have information from blood tests, the data, this is information. If you discover rules, if you provide dependencies about these parameters, this is knowledge. Okay? We will see that artificial intelligence has used several languages to represent knowledge, such as mathematical logic, which is an old field that AI has borrowed from mathematics. In other situations, it is more convenient to use other languages to deal with uncertainty. For instance, the language of Bayesian networks allows us to represent in a suitable way probability distributions and answer queries about probabilities efficiently. In the first lesson of the unit, we will introduce machine learning. We will see that the goal of machine learning is to adapt our knowledge to changing situations. For instance, when new information arrives, like in dynamic environments, or to learn from past experiences, like learning from mistakes. So the goal of machine learning is to acquire new knowledge or new capabilities. We will introduce the 3 main paradigms of machine learning. They are supervised learning, where the algorithm receives examples of the concept of the idea that needs to be learned. And supervised learning, where the algorithm receives raw data and is supposed to discover properties, patterns out of this data. And then reinforcement learning, where the algorithm receives feedback about its behavior and learns from the experience. Once we know the essentials of artificial intelligence, we will be ready in lesson number 5 to overview the main applications where AI plays a key role. And we will be able to identify in these applications where is the artificial intelligence component. We will see applications in sectors like consumer products, commerce, or industry. Since so many AI products are being deployed in the last years, there has been a search of languages and libraries that allow us fast prototyping and development. and development. We will see some of these languages whose goal is to facilitate development for non-experts and still keeping the efficiency of the algorithms. In the last lesson of the unit, we will address some ethical implications of artificial intelligence. Through the many devices that you have, different AI systems are watching you all the time. And they are building a model of your behavior so that they can predict what you are going to do, and then they can act accordingly. This level of intrusion has raised the concerns of many well-informed citizens. So we believe that information and communication technology professionals cannot avoid their responsibility. In words of former ACM president, ICT professionals are the first and last line of defense against the misuse of technology, because they understand better than anybody else the potential and limitation of the algorithms. In this context, we will close the unit covering some topics that we believe need to be treated with care. For instance, we will discuss the dangers of algorithmic bias or the dangers of giving away our privacy. We will also talk about the need of algorithmic accountability and the obligation of professionals being prudent about when explaining their products.